I'm excited about this episode because, as you can see on the workbench, we are going to learn how to control the electric motors that comes with the ev3 Mindstorm. And I have already made the connections to port A and port C. So just take your Mindstorm, pick one of the large motors and the medium motor if it comes with your kit. And I want you to make a connection to port A on your brick from the large motor, and then port C to your medium motor. I already have some program written and I'm going to run it for us to see before I explain the code. So I've started running the program, and after a while we should see the motors moving. Now I want you to take note of the difference in speed between the medium motor and the large motor. Alright, so now that we've seen the motors are actually moving, let's come to the code view and see how to control the electric motors. The first thing I want you to remember is the maximum rated speed for the medium motor and the large motor are different. For the medium motor, the maximum rated speed is 1560 degrees per second. So if you set the medium motor to move at 100% of its speed, then it is going to sweep 1560 degrees per second. For the large motor, the maximum rated speed is 1050. So if you set it to travel at 100% of its speed, it is going to sweep 1050 degrees per second. So let me add some comment here. Let me add a comment here and say max speed. So max speed for this is equal to 1560. Sorry, this is large motor, so 1050 degrees per second. And when we come to the medium motor, the max speed is equal to 1560. Now, when it comes to controlling electric motors with the ev3 Mindstorm, there are three things you may want to do. The first and easiest is what I'm going to show in this video, and in subsequent videos I will show how to do the rest. The first thing you might want to do is to simply turn on the motor at a certain speed, and knowing very well that somewhere in your program you will turn the motors off. When you turn the motors off are dependent on the type of robot or the need of the robot that you are building. The first things we need to do are to import the classes and constants that we need from the right modules. To be able to control the motors, we need to make these import from the motor package or module. We need to import the medium motor if we want to control the medium motor. And as you can see on the workbench, this is the medium motor. And this right here is the large motor. We usually use these for the wheels of a robot and these for other things. It all depends on the build that you are making. Okay, so what we do is we import large motor. I also had medium motor here, sorry, yeah. So we import medium motor, large motor, and when you connect the motors to the brick, you need to take note of the port that you have connected them to. The ev3 Mindstorm brick comes with 4 ports, and there are constants created for them. So we have output A, B, C, and D. So you instantiate a motor using the large motor or medium motor class, depending on which one you want to control. But for both of them, you need to specify the output port to which they are connected. Once this is done, all you have to do is to call the motor.on function, and you specify the speed at which you want the motor to travel. Remember that the speed you are specifying here is a percentage of the maximum speed that the motor is able to travel at. So when I specify 50, I am not saying the motor should travel 50 degrees per second. Instead, I am saying it should travel 50% of its maximum rated speed. So on line 10 here, specifying 50 as the speed for the large motor means it should travel at 50% of 1050, which is 525 degrees per second. If I specify 100, it means I want to travel at 100% of the maximum rated speed, which is 1050 for the large motor. The same logic applies to the medium motor. Now, one thing I want you to take note of is that the calls to the on function is not blocking. What I mean by that is if you call on for the motor and you don't wait, or you don't sleep, the motors are going to stop spinning the moment your program ends. And you know your program ends when the last program statement is executed. So when you set the motor on, it's either you're going to sleep for some time so that the motor finishes what it's supposed to do, or you do it in a loop so that the motor finishes when you want it to finish. Otherwise, it is not going to work. To demonstrate this, let's go to the workbench and see what this code achieves. We'll come back, make changes, and then you understand why I said it is non-blocking. So I'm going to switch to the workbench and I'm going to run the code that you saw. Remember that both the large motor and the medium motors are set to travel at 50%. But you can see that because the medium motor's maximum rated speed is higher than the large motor, even though they are set to 50%, the medium motor travels faster than the large motor. Okay, so now let's come back to our code view and make some modifications. So inside the code view, what I'm going to do now is to comment out this line where we wait and we sleep. And let's see what the effect is going to be. So we go back to the workbench and I will run this program. So I'm switching back to the workbench. And over here, I'm going to run the program you just saw. Let's wait for the program to come. You can see that this time around, the motor started spinning and it stopped immediately. And the reason is that there is no sleep call here. So yes, the brake is going to start the motors and it reaches the end of the program. And once your main program has ended, everything that is started is also going to end. So always remember that you are either going to sleep for the time that you want the motors to be running, or you can also do it in an infinite loop if that is what your program calls for. So I can say while true. And if I do this and you indent properly, this is an infinite loop, okay? And so you need to find a way to break out of it. This is one way of doing it. Otherwise, you can go back to what we had and sleep for a while. So time.sleep. So let's say I want it to be running for 5 seconds, after which I can turn them off. So I can say left motor.off, and I can also say medium motor.off. So I'm going to go to the workbench and then we'll see the effect of this code. So I'm going to run the program you saw, and we expect these motors to run for 5 seconds and stop on their own. So after 5 seconds, they have all stopped. This is the simplest way of controlling your motors. However, you agree with me that it is not always intuitive which value you should set for the speed. It's either you have to do the calculation of the degrees per second you want them to sweep on your own and then calculate the percentage. However, the ev3dev2 modules gives us functions that we can use to achieve the same purpose. And so if you come to the code view, you can see that I have imported some other functions here. The first one is speed DPS, which stands for speed degrees per second. This is speed revolutions per second. And this stands for speed revolutions per minute. Like I said, it is not always intuitive which value you should set as the percentage for the speed. It is easier for you to say, I want my motor to run at 100 degrees per second, rather than saying I want it to run at 30% of its speed. And that is what these functions are meant for. So if I want this motor to travel at 100 degrees per second, you call the appropriate conversion function, which is going to take in the degrees per second you want it to travel, and it will return the correct percentage because it knows if you are using it in a large motor or a medium motor, and it will calculate the percentage very well. So why don't we set the large motor to travel at 100 degrees per second? So I do 100 degrees per second, and we are not going to let the medium motors run this time around. So let's turn those lines off. And so with this line of code, let's go back to the workbench and see what we have there. So having done these changes, we expect that only the large motor is going to travel at 100 degrees per second. So let's wait, and you can see that it is indeed sweeping 100 degrees every second, and it does that for 5 seconds and it stops. Let's go back to the code view and see how we can reverse the directions that the motors are traveling at. When you specify a negative speed, it indicates that you want the motors to travel in the reverse direction. So over here, I can just negate whatever comes, or I can also say I want it to travel negative 100 degrees per second. So initially, our motor was traveling clockwise. Now we can make it travel counterclockwise. So I'm going to switch to the workbench, and then we run this code to see what we have produced. So we expect that this motor is this time around going to travel counterclockwise. And you can see that indeed it has traveled counterclockwise. So the same thing applies for the speed RPS. Over here, you specify your speed in revolutions per second. So if you want your motor to make 1 revolution in a second, you can specify it. If you want it to make revolutions per minute, you can also use this speed RPM function to convert to the right percentage to be sent to the motor for it to turn. So this is it about just turning on your motor and knowing very well that somewhere in your program you are going to turn them off. In the next video, we are going to take a look at how we can let the motor sweep a specific angle at a specific speed. So thank you very much for watching this, and I'll see you in the next.